Hi,
Hi, everybody. Good afternoon. I am just letting us all in here. We have a bunch of us coming in. All right. And then for those of us who are here, we're going to go ahead and get into the quick check-in questions. So I could double check our attendance and who's here. But welcome, everyone. It is October 1st. Already October. All right. So our quick check-in is put the name of a bug, any bug, in the chat. And then I'll double check who's here. Oh, yeah. Hi, Danny. All right, we got ant, stick bug. Those are always interesting to me. And they're creepy because they move. Moth, mosquito, roach, a beetle, ladybug, scorpion, cricket. Yeah, fly. I hate flies, but yes. Caterpillar, yeah, and ladybug. All right, so I'm just double checking who we have here. Bed bugs. Ugh. All right, let's see. Now there's something called a land lobster and roaches. All right, so this is who I don't have, and y'all can double check with me. This is based on this quick attendance check. Jalen Baker, do we have Jalen Baker? Denise,
yeah,
Jalen Baker, you're here. All right, sorry about that. All right, do we have Denise, Alexander, Carlos, Yaisa, Sincere? I thought I saw Sincere. Are you here, Sincere? No, Sincere? Okay. And then lastly, Ryan. So that's who I'm missing. And let me repeat. And if you're friends with them, you guys can send them a text or something to let them know class is starting. Again, I'm sorry. So this is who we're missing overall. My bad. Tori Brown, Denise, Alexander, Carlos, Yaisa, Sincere, and Ryan. So that's who I'm missing. Again, if you're friends with them, let them know. Send them a text to come on into class. And we just have Alexander coming in. Awesome. Thank you all for sharing in that chat. Check in all the bugs y'all thought of. As y'all were typing, I was thinking about roly polies. But yeah, all right. So welcome everybody. Let's jump into our spider agenda. So this is what we're doing here. So we just took the attendance. We did our little quick check in there into the chat. Then what we're going to jump into is the similarities and differences activity from asynchronous number 7. Now, asynchronous number 7 is due tonight actually, but some of us already did some of the work. So I went ahead and took some sample student work so we could do similarities and differences activity with it. We're going to do that. We're going to talk about it a bit. Then we're going to move on to talk about the summative assessment. So that's basically our mini final. We're going to talk a little bit about that. And then the last step is we're going to interact with our summative resources, doing a little bit of annotation today at the last portion of class. Um, So questions about the summative slash mini final, let's hold on to those until a bit. It will be due Sunday, but like I said, let's hold on until I talk about that after our activity on similarities and differences. And I'll talk about the deadline and so forth, but y'all can read that. Like I said, let's hold on to the questions. And I have to put in the attendance here. All right. So let's jump into the similarities and differences activity. So for this activity, what I have for you is question number 5. Sorry. Before we jump into that, just a review of what we did in our last class. At the end of the last class, we talked about the steps to finding an inverse function, and we copied down this specific example. So this right here, you already have. I'm just reviewing with you the steps. So if you remember, our first step was to rewrite that f of x as y. And right here, my drawing tool, remember that first step that correlates with this one. Second step was to switch the x and the y. Second step. Third step is you solve the equation from step 2 for y. So you got to get this by itself. We did our steps and we got y by itself right here. And then the last and very last step is if you have a function, you replace it with the proper inverse notation. So that's just an overview of what we did last time. You already have this in your notes. I'm just kind of verbally going over that so you could kind of just remember that again before we jump into the similarities and differences activity. I saw something in the chat here. Let's see. Yeah. Oh, someone said roly polies were my friends. Oh, same. Okay. Let's go on to the similarity and differences activity. So this is what it is. So some of you already did question number 5 on asynchronous number 7. Now this is due tonight, but I went ahead and I took screenshots of some of the student work I saw already. So we could talk about it because I'm noticing some some differences in thought here. So here's the question up here. For those of you who haven't yet looked at the assignment, I mean, here's the time to look at it, and here's some of the work. So it's beneficial for those who already did it and for those who haven't yet. All right, so the problem says attempt to find the equation of the inverse of this here function, 2x squared minus 1, using the steps that we discussed in class. I also, in your assignment, inserted the class recording in there, so you could always go back, go to the last 10 to 5 minutes to review those steps and to like apply them. And then I mentioned that this is an attempt, right? And show all your steps and try your best. So that's just the goal. Both of these students attempted this, showed their steps, and tried their best. As you can see, like all the steps written out, they tried to follow the steps. Okay, awesome. So let's go ahead and begin the similarities and differences activity. Now for this, it is participation, so everyone should be participating in this. Question number 1. What is similar between these two pieces of student work? And I'm circling right now, we're just doing similarities. You could go ahead and answer into the chat. What is similar between these two pieces of work? All right, we got some stuff coming up, yay. I'm also retyping the question there into the chat. All right, so what is similar? We have, they both switch X and Y. Yeah, their step 2 looks pretty solid. I see that switch in the X. Well, kind of. Yeah, they both do an attempt on the switching of X and Y. Danny put their answers look similar. Yeah, like I see that there's X over 2 over here. I see there's X over 2. I see 1/2. I see 1/2. The answers do look similar. AJ says they both use the same steps. Yeah, they're both, you could tell they're both looking at the same directions, right? They both have the same steps, 1 and 2. All right, so 1 and 2 looks the same. The first 3 steps of, so Zion thinks the first 3 steps are actually the same. Okay. And I got a private one. Oh, okay, that's okay. They did the first step the same, is what Leon says. Again, step 1 and 2, the same steps at the beginning, similar 1 and 2 step. The first 2 steps are the same. Okay. All right. Let us know if there's any other similarities, if anything wasn't mentioned just yet into the chat. What else could be similar between these two pieces of work? Mhm. All right. Let's go ahead and pause here. Let's sink in what we saw was similar. All right, now please look deeply at these two pieces of work. And again, one student typed out their work using the equation stuff on Google Docs. The other student submitted a picture of their work. They're both, equally valid. Either one works. Now let's do the differences. So now what is different between these two pieces of work? So different. I'll go ahead and I know I see some of you already starting on that. I'm going to jump to that in a second. But right now, differences. All right, let me read some of this. The difference is that on the right, on the left side, they didn't square to get 2y by itself. They didn't square to get the 2y by itself. Hmm. All right, let's see what else we got. One student adds +1 on both sides and the other one didn't. Now this was sent to me privately. So one student adds +1 to both sides and the other one didn't. So let's see, I see that happening here. Okay, +1 both sides. And yeah, I don't see the +1 over here. So I agree with that. Danny said step 2 inserted Y. So for that one, I probably would need some more information about the inserted Y. One square roots and the other one doesn't. Oh, that's a major difference. Yeah. The student right here on the right-hand side is using square roots, whereas the other student doesn't. And then another one private messaged me the same thing. There's square roots and the other one doesn't. They both did the step 3 different. Yeah. Specifically, I wonder what's different about step 3, if we could get a little bit more precise. Let me also let in someone. Hold on. All right. One person squared, the other one didn't square to get the y by itself. Awesome. On the right, there's a lot of squaring and square rooting, and the other one does not. And then Brandon says the end looks different. The end looks different. Awesome, awesome. All right, cool. So let's see if there's any other differences that we notice here between these two pieces of work. Any last minute differences? Okay, great. So now the question is, well, who's right then, right? These two works, they have some different stuff going on. Who's right? Well, let's go ahead and find out. So we as a class didn't yet talk about how to tackle, when you have squares happening in your answer and so forth. But we're gonna go ahead and talk about that. Um, Great. So how we're going to go talk about this is I need to actually transition into my, so who is correct? I need to go to PowerPoint because again, on my PowerPoint is how I could show equations. So I'm going to go to that and we're going to look at the answer and who's correct. Oops. Well, give me a second. There we go. Okay, now we don't see anything. All right, so let's talk about this problem. Again, this problem is question number 5 and asynchronous number 7. And we were just looking at student work. And we're going to go ahead and see who is more correct or not. Are they both wrong? Are they both correct? I don't know. Let's see. So step 1, they both did step 1. If you remember from looking at the student work, they replaced f of x with y. Awesome. Step 2, switch the x and the y. And I think that's what was different from the first student work and the second student work. I don't know if y'all noticed it, but I could go ahead and point it back out once we head back into my other slides. But I think the student on the left-hand side made these both X's instead of an X and a Y. And when I'm on PowerPoint, for some reason, my mouse disappears. So I'm gonna have to try to not use the annotation tool. Okay, go to mouse. 1 second. Technical difficulties. Hold on. Come on, we're almost there. Okay, yeah, I can't get rid of my annotation toolbox, but let's keep going. Okay, and then step 3 is we need to try to solve for y. So again, I can't use my annotation tool right now, it's acting up, so I'm just gonna try to verbally describe what's happening here. All right, so to get y by itself, I'm gonna use the strategy that the student on the right-hand side, if you remember, did. Some of you pointed it out, they did +1 to both sides. Yeah, you do +1 to both sides to get rid of that -1, right? That gets rid of it, and we could get that y by itself because that's the goal for step 3. Once we do this, we should get this. On the left-hand side, you get x plus 1. On the right-hand side, you get 2 times y squared. All right. Maybe I could get some can I open up the chat? Yeah. Maybe I could get some participants in the chat to go ahead and tell me what should I do for my next step here. Maybe you could use some of the ideas that you saw in the student work or come up with your own. So Risha went ahead in the chat and she put divide by 2. Yeah, I agree with that. The opposite of multiplication is division. Let's get rid of that 2 because that's 2 times y squared. The opposite's division. And then someone private messaged me, maybe square root later. Then put never mind. I don't know. Let's see. Great. So I'm going to take Risha's suggestion. I'm going to divide both sides by 2. I'm doing this motion because the 2 cancels out. This right here cancels out. And you get x plus 1 divided by 2 is equal to y squared. Now, if you take a look at this, remember the goal of step 3 is to get y completely by itself. Now, the y is still not completely by itself. What do y'all think? Because there's a squared. What do we do to kind of get rid of that squared? All right, so Brenda put square root both sides. Maybe that's where that student came up with that square root in the right-hand side example that we looked at. Yeah, so to get rid of a squared, you square root. For example, if you had 2 squared, take the square root of 2 squared, that's the square root of 4, you get 2. Zion, you put divide. Let me know what you mean divide by what, so I could jump into that. I'm gonna go ahead and take the Brenda suggestion, because I also saw it in that student piece of work to kind of see where they got that from. So we're gonna go ahead and square root both sides. If y'all remember this from Algebra 2 or from your past algebra classes, a square root gets rid of a square. So basically square rooting both sides will get rid of this square. Basically they undo each other. They're opposite operations. Notice that? When I square root it here, the y is finally by itself. And over here, you actually have to remember that when you square root both sides, you got to do plus minus in your final answer. And the reasoning for that, and hold on a sec, I thought somebody was trying to join the classroom. The reasoning that you need to put plus or minus is, for example, let me see if I could write something out as to the y on the plus or minus. Yeah, let's say if you had something like x, the square root of x squared. X, for example, let's say can be 4. I'm sorry, x squared can be 4. Sorry, let me do this. Equals 2. There we go. So my x could be positive 2, right? 2 squared gives me 4, and the square root of 4 gives me 2. Or x could be, and now where is my tool? What's over there? Yep. Or x could be negative 2, because if you do negative 2 and you square it, negative 2 times negative 2 is also positive 4. Take the square root of that, you get 2. So that's why when you square root both sides, you got to put plus or minus, because you get a positive answer and a negative answer. And I'm sorry that my work looks so messy down there, but that's the why for that. Why you got to put the plus or minus when you square root both sides in an equation. So let me go ahead and get to the next step right here. And in order to do that, because I used my annotation tool, so it's going to be a little bit tricky to get out of here. Where am I? Okay, I'm over here. Yay. All right. And then I want to clear my drawings. So there we go. So step 4, notice how I did step 4. The answer is plus or minus the square root of x plus 1 all divided by 2 equals inverse. Now, I specifically did not put equals f inverse of x, and it's for a specific reason that I did not do that, that I'm going to talk about. So I can't actually write f inverse of x, sorry. And let me see if I could use my tool now. So I can't write, yeah, I can now, f inverse of x. I cannot do that because actually, you're going to see right now when I graph this equation on Desmos, you're going to see when I graph it that it's not a function. It's going to fail the vertical line test. So that's why instead of writing this proper inverse notation for a function, I did not do that. I just said equals inverse. So that's just a major thing here. Make sure you get this down, and I'll go ahead and clear. So again, I can't do this. So I cannot write inverse because it's actually not a function.
So you write inverse, but you don't use the inverse symbol?
Yeah, that's correct. Yeah, technically that's what's going on here because it's very technical, and you'll see once we graph this on Desmos why we cannot call it a function. We can't say inverse function, but we can say it's an inverse for this one. But let me just give everyone some time to just process the steps, get this down. Okay, and then Brenda put a clarifying question there in the chat about that same thing. So if it's a parabola and the inverse is rotated, it's not a function and we write inverse. Yeah, that makes sense. I think that's a good way to kind of rephrase what I just said. Yes. Y'all could take a look at that, what Brenda put in the chat. All right, so okay, so Zion, you asked how come I put plus or minus right beside the square root. So for the same reason that I gave that other example. So for example, if you have the square root of x squared, so that's kind of what I did before when I was, the only problem was that it was kind of hard. So if I have something like this kind of equation, and I say the answer is 2, x can be 2 different things. It could be positive 2, or it could be negative 2. So 2 squared is 4, and if I take the square root of 4, it gives me 2. But if I also do negative 2 and square it, because negative 2 times negative 2 also gives me 4, the square root of 4 gives me 2. And let's take a look at the chat here. So yeah, hopefully Zion, that makes sense. Or it looks like Danny says, probably because of the U shape. Yeah, it is because of the U shape. Y'all are going to see that actually right now when I show it on Desmos. Yes, because of the U shape, right? When you rotate it, you're going to see. Let me go ahead and move on to the Desmos so y'all can visually see this. And then we could go back to the student work, see who was right, who's more there as far as the accuracy. So I'm going to first write down this inverse because you know what? I forget stuff. We need to graph plus or minus x plus the square root of x plus 1 divided by 2. We're going to graph that up. Let me show you how we do this. And I'm going to clear my annotations, clear all drawings, and let's go to Desmos. All right, so on Desmos, here's the thing. Desmos does not have plus or minus thing that, you know, Zion, you were asking about. It does not have plus or minus. So what we need to do is kind of graph them separately. So let me go ahead and do that. You go down here to get your tools that you need. Here's the square root. And I'm going to do the positive one first. So I'm going to do the square root of x plus 1 divided by 2. That was one of them. So that's 1. See how that's half of it? So maybe that's the mentioning about why it was a U shape. And then remember that was plus or minus. So now I have to do the minus version of this equation. So I'm going to just copy, paste it. Now I got to put minus. Boom. See how you get your full U when you do that plus or minus? So it kind of makes sense. So that right here, what I graphed is the inverse. And I'm not saying inverse function because it's not a function, right? If we test it using that vertical line test, look at this. It's going to fail it, right? Because it crosses more than once. It crosses here and it crosses here because this is two parts of it. Now let me show you. If I draw the original function, let me get out of my annotations. Here's the original. So the original problem was y equals 2x squared, and it was minus 1. Look at that. So see how they are a reflection of each other across that special line that we were talking about yesterday when we did the Desmos exploration. So in order to get the full inverse, we needed to do plus or minus, the red and the blue right there, to get the full inverse, because otherwise you would have just gotten half the graph. And yeah. And that's what Brenda mentioned there in the chat is, oh yeah, Miss Walker's here, by the way, everyone. If y'all remember her, Miss Walker, she was also working with Algebra 2's Miss Walker, I believe last year. So she's joining us here today in the chat. Awesome. So how do you use this info to make a table out of the equation was a question that was asked to me privately. So for that one, I hope we could come back to that because I think that's a question related to async number 7. But how you make a table is you usually do the original function, choose some inputs, make some outputs. Once you have that, all you got to do is you just flip the x and y values, very similar to what we did in the Desmos activity yesterday. But for any questions on help on async number 7, message me on Remind as well, and I could totally help you out. But there we go. And again, I want to also add in that special line that we talked about yesterday, that reflection. Remember, it's that diagonal down here. That special line is called y equals x. And that reflection is happening here. Let me go ahead and... So it's a reflected U across this special line. It's like a mirror image across this line. And again, we're saying that this is the inverse, but the inverse is not a function. All right. You thought Miss Walker from Algebra 2 was here. All right, y'all. So I'm going to go ahead and go back to the student work that we had. Let's take a look. So, and I'm going to go ahead and delete my annotations here. All right, so here's our student work. Who would you say was kind of in the almost there with their answer? You can go ahead and use the chat. Who would you say was almost there? Student sample 1 or student sample 2? Who's almost there as far as? All right, so it's student B, so I guess we'll say student sample 2. All right, cool. So and I see how we can see that because that student remembered about the square rooting. The student also did the accurate switch right here. If you notice that, like I kind of see the X and Y's got swapped. The student accidentally, or I don't know if that was intentional, kept both X's there, but you got to swap the X and the Y. And they also square rooted here. The only thing that was probably missing there is the plus or minus portion, which we just talked about. So yeah, awesome, y'all. Great, so I'm hoping that this kind of helps you out as y'all are continuing to work on that assignment. Again, it is due tonight, midnight. Let's go ahead and move on from that so we can jump into discussion of the mini final that we're going to be having. All right. So all our learning from this unit is going to be put together in something we call the summative task. Again, I'm going to be using summative task, or I might be calling it mini final. They're going to mean the same thing. It is already posted on Google Classroom is the first thing you should know. Second thing is Yes, this is the mini final for this module. So at the end of every module, you have like a mini final. This is graded on accuracy. So this is graded on a rubric. So it's emerging, developing, proficient, or advanced. But the cool thing, and that's the great thing, is that you can always resubmit it. So let's say I grade it, I give it back to you. I'm like, hey, this is developing. Here's my feedback, or here's student feedback. So you're going to be looking at each other's work. You're going to make some edits based on that. Here's feedback for you. You could resubmit it. And you could resubmit this actually as many times as you'd like, even if the module's already done. I'm totally still accepting it. So I'm always going to accept resubmissions, and you could always improve whatever score you got on it. So that's just the cool thing. And as far as what resources you have, that's going to be the focus on today. So you have these slides. So that's one resource you have. You could go back to these slides. You also have the videos. If you do request it from me, I could send you any of the videos if you missed a lesson or anything like that. I have recordings of those. But most importantly, you have these slides, and you have something called the Big Ideas Packet Unit 1, which we're going to explore today. It's going to help guide and support you as you're working on the summative task. And we're going to be looking through the resources today, again, specifically the Big Ideas packet. And this is an overview of what's going to happen to lead us into the end of the module. So step one, you're going to explore what resources that you have, right? Slides, Big Ideas packet, questions, you know, things like that. What resources do you have? You also have each other, by the way. You could always text each other stuff, questions. After you go ahead and you know what resources you're using, you're going to go ahead and start on the summative or the mini final. And that's, again, it's already posted. It's due on Sunday. The expectation is you show all your work, your thought process. It's like your first draft is on Sunday. You got to show all your work, though, for it to be a first draft. Very similar to the student samples I showed you. They both showed their work. That's like, you know, a great draft for the first, for those students. Then lastly, what you're going to be doing after you submit this draft Sunday is Monday, when we come back, we're going to be doing peer feedback, and also, like, hopefully by the end of that class time, doing some resubmissions based on the feedback you got. So that's just a rundown of what's going to happen. Yeah, and let me know if anyone has any questions on the process so far, like any questions on the process before we jump into the next thing, which is looking at the Big Ideas packet. Awesome. And then there's some happiness that it's due Sunday. Yeah. All right. Awesome. Awesome. I don't see any questions. So let's go on to the next part of this. All right. So if you go to our Google Classroom, right, and you got to click on classwork, because if you click on the stream, right, you're just going to see a bunch of stuff. It gets overwhelming. I would go to classwork because it's organized by unit and by week. So right now we're in unit 1, week 3. What you have due tonight is asynchronous number 7, which we talked about right now. What we're going to be looking at, though, for the next segment is this one here, the Big Ideas packet. So if everyone can go ahead, go to Google Classroom, and please click on this to open up the Big Ideas packet. All right, making sure everyone knows where we're at, and I'm going to go and join you in a second. All right, awesome. I hope you all have the Big Ideas packet open. Let me go ahead and talk about what we're going to be doing with the Big Ideas packet right now for the next about 15-ish minutes. A copy and everything, right? I think that make a copy. Yes, you're going to make a copy of the Big Ideas packet. That's correct. And for the next 15 minutes, here's what we're going to be doing and submitting, right, in the next 15 minutes. Step one, yeah. So Danny, this is exactly where I was going to head to. You're going to go to Google Classroom. You're going to make a copy of the Big Ideas packet. Step two, once you make your copy, you're going to annotate it by making comments. I'll show you what this looks like in a bit. I have an exemplar from last year. This is how you're going to annotate your Big Ideas packet. You're going to highlight a portion of it and you're going to comment either a clarifying question like, oh, I don't get this part, let me just ask a question. Or if you don't have questions, you're going to highlight a portion and rephrase your understanding in your own words as a comment. Let me show you what that looks like though. And you're going to do this for a total of 5 comments. So a total of 5 comments for any 5 concepts or 5 examples. Total of 5 comments. And that's what you're going to be submitting to me today by the end of class. Once you finish, go ahead and submit. And we're going to have about 15 minutes. Again, just 5 comments, highlight, ask a question, highlight, or rephrase. Let me show you an example from last year, for an exemplar. So this one was Big Ideas Annotations for Chapter 7. We will be doing Chapter 7 in this class, but let me go ahead and jump to the comments this particular student made. So right here, this particular student had a question on this big idea, and they asked their question. Now, last year we had time where students actually were able to answer each other's questions. We might not have time this year, but this was an example of a comment that was made. So that counts as a comment. Okay, that's a question. This one right here, notice it's not a question. This student right here highlighted the big idea and rephrased the understanding in their own words. So notice you can make a comment as a question or a rephrasing of your understanding. So again, there's further examples how to do this. Again, this one right here is not a question. She is rephrasing her understanding in her own words, like in her own, you know, the language that you all use to talk about stuff. Like without the, you know, jargon and so forth. Again, this is a rephrasing. Yeah. So let me know if anyone has any clarifying questions about how to make the comments on the document, but I went ahead and talked about that right now. We're going to be using the next 15 minutes to go ahead, follow the instructions, make your comments, and you're going to submit this to me by the end of class today in the next 15 minutes. Any questions before we get started on this? All right, everybody. Oh, I think I see something in the chat. Okay, so Zion, you asked if I can repeat what we do. Yeah, so it's also written up here. First, you made a copy of the Big Ideas packet. Step 2, once you make your copy, you're going to annotate it. You're going to annotate it by highlighting and commenting. Either you're commenting a clarifying question on a concept or example for a total of 5 concepts and examples, or if you don't have questions, you're going to highlight a portion and rephrase your understanding in your own words as a comment, just like I showed Sophia's work from last year. Then once you're finished, you're going to submit a copy. So it's kind of all written here. Do you need me to kind of go back to the exemplar, Zion? Or are you okay with what I repeated? Okay, perfect. All right, y'all. Let's go ahead and have about 15 minutes, and we'll come back in about 15 minutes for our closing, for our checkout question, and that will be it. So I'm going to go ahead and turn off my camera and mic so y'all can focus, and I'll be here though, so use the chat for any questions that you have. All right, everyone, let's begin. All right, we're about 5 minutes in, so I'm just giving an update. I'm just looking through the comments that are being made so far. I'm putting some in the chat that I like. It's taking me some time, but I want to deeply like read what y'all are saying. Also, just to clarify, you're making a total of 5 comments. It's not 10. So someone thought we had to do 10, just 5 overall comments. All right, I'll see y'all in 5 minutes. All right, everybody, welcome back. So if you're still working on making your 5 comments, I mean, you want to go ahead and make sure you finish that. Let me stop this timer. So that was the end of that full 15 minutes that we had. So if you check out the chat, I was looking in through some of the comments that y'all were making on the Big Ideas packet. I was taking a bit, but I was trying to make sure I got at least a comment from one student and then moved on to another student. So you might see some of the questions you asked or some of the rephrasing you had. Again, some of us might know the answers to those questions and so forth. We'll explore that once we have, like, peer feedback and so forth. So now what I'd like us to do is, number one, so first off, make sure tonight asynchronous number 7 is due, and so is this, right? Make sure you submit this. Let's go ahead and transition into our exit now, our closing. And here's our closing. So what questions or understandings did you have from the Big Ideas packet, our resource? Go ahead and put down one thing, one question or an understanding into the chat for us. It could be something you already wrote down. You could just go ahead and repeat that, copy and paste it, or any other questions or understandings you have in general. All right, so a question that Miles has is, to find the inverse, can you just switch the signs? So that's a question there. I understand today's lesson way better than I did yesterday. Yay, that's awesome. I'm so happy to hear that. And good question, Miles, by the way. Good question. That's a good question. Maybe some of us are thinking about that too, about the inverse. Can we go back and look at it as a resource for the final? Yeah, of course. That's what you're going to be doing. So right after I see that you've done this, I'm going to give this right back to you because you need the Big Ideas packet to do the mini final. So yes, you will look back at this as a resource. And then I don't know if that's a question or understanding. I understand function composition way more. I don't know if that's a question or not, AJ. I understand this stuff better since I wasn't here. We have a private one. A parabola fails the vertical line test because of its shape being U. Interesting. Is it open note? Yeah, it's open note because you're going to be doing this at home. You're going to be using your resources, all your notes you took, everything. Someone private messaged me, sideways parabolas are not functions. And then AJ, that was an understanding. Yeah, you understand function composition better. That's awesome. So CJ says, at the end of the day, the Big Ideas packet is no different from the notes everyone should have taken. Ooh, ooh. Wow, okay, awesome. Thank you for adding that, CJ. These are awesome takeaways from this. Let us know. Again, it could either be private or through the whole group chat. What questions or understandings did you have from what we just did right now, the Big Ideas packet unit 1? All right, y'all. So as I go ahead and close this up, I am so excited to see what kind of questions and rephrasings y'all came up with. Again, this is a learning process, and I'm excited to see what comes out of it. Again, all the stuff that's due, it's going to be on Google Classroom, so just head to there for if you're uncertain. All right. Thank you all. Thank you so much. And I see some more private messages. So understand. All right, y'all have a great day. I'll see you later, whenever I see you, or talk with you later. Bye, y'all. Have a great day.
Bye.
Bye. Yeah, bye, bye, Tamira. All right. Bye, everybody. Bye.